Hello everyone, my name is Sunil Pareek and today we are starting a new topic which is EVPN. So basics of EVPN. What we will be doing is we will be learning some of the EVPN concepts and this will be a series of lectures, and today it's our first lecture on this where we will be covering basically the reasons behind EVPN. And here, as a part of this series, basically what is the learning objective? So this objective that I'm showing here or will be showing, that is for this whole series. So what we will be looking at is understand why you need to learn EVPN if you are in the field of networking, supporting any type of network. Why basically you need to invest time and learn EVPN. Then we will be looking at some of the BGP know-hows, EVPN route types, and we will also be covering at some of the deployment guidelines around EVPN. Since I got the opportunity to work on these technologies in multiple sectors, and what I mean by multiple sectors is we'll be talking about in this video. And so what was the learning from those sectors is what we will be looking at. So for today, for this particular lecture, what we will be focusing on is this first piece where we will uncover why you need to learn EVPN. So that will be the agenda for today. Why? First of all, you need to learn, and then while we are discovering all these reasons that one should learn EVPN, we will also understand what were the key driving factors around EVPN that make this technology so special that it is started its route from the data center, then it came to service providers, and now it is even penetrating into the campus enterprise networks as well. So we will cover these reasons. In this video, what we will be looking at is we will look at DC network evolutions, then we will come to the campus network evolutions, and also we will be looking at a service provider network and what are the challenges those are faced by these networks that had eventually turned all of them towards this. So that will be our topic, and normally if you look at the engineers like myself, we work either in the data center technologies or on the service provider side or on the campus network, but there is still some sort of overlap, but these are the technology groups where engineers work with different levels of customers or with different level of organizations. If I look at the vendor side or even in the customer segments as well, there are like engineers working specifically or have expertise specifically into each of these streams. And if you are someone who follow the certifications, let's say there is a very famous popular one from Cisco side, they have the CCI track even for data center, service providers, enterprises, right? So even they also look at it like three different set of domains. But what we will be looking at in this lecture today is that how they are adopting the EVPN and what are the basic business drivers behind it, right? So first of all, any typical network deployment, if we look, it used to connect compute and then the storage network. And with the evolution of virtualization, right, there were physical set of these servers where a lot of VMs got deployed. And with the innovations that had happened around compute, around storage, where initially the storage was like physically connected to the compute servers, then they had like decoupled it, and the storage can be connected over a network as well, right? So to if a compute want to talk to the storage, what it basically need is a network, right? This is a typical network that is applicable even for enterprise, that is even applicable for data centers as well. When I say data centers, I'm talking about the legacy data centers, how the network used to be deployed at that time in campus, in data centers. And in this video, we will be looking at like what were the problems with these networks, with all these innovations that were happening on the adjacent domains, right? And then this was like uh, stagnant for quite some time, and then it picked up the pace with all these new requirements, right? And so we will be basically covering at where we started versus where we are in terms of the three domains that I was talking, right? Data center, service providers, and the enterprise segment. So first, let's just start our journey with the data center. And I was fortunate enough to work and see this evolutions. So the first type of network when I started my career was something that used to look like this, where we have our access layer, then aggregation layer, and then the core layer. And we used to normally configure the gateways here, and the servers can be connected anywhere. And in this case, since it was extended till here, the layer 2 boundaries, there were some obvious issues, right? We will not spend much time, but most of you remember spanning tree, right? That used to block half of the links just to avoid any loops into the network. So even though I'm provisioning the capacity, I'm connecting additional links, but they will be kept in the blocking state when we build such redundancy in a layer 2 network. And again, I'm talking about the legacy layer 2 network where STP was the only player. And after that, we will see like what all evolutions that had happened in this. And so I remember somewhere around 2008, 2009 time frame, I had seen one customer who was complaining that now with these virtualized servers, I'm connecting less servers to the network, but still the amount of SFPs or the amount of link that are there in your network are much more than the endpoints in the data centers that I have. And those actually result in a cost to me. So the point why I'm making this is it was not only the problem of blocking links, right? It was also resulting in some of the additional cost that of lately customers have started to realize. And of course, there were some more challenges, but will not spend because there are many uh, videos or contents exist around which talks about the problems of these. So we will come uh, uh, fast forward to a network like this. Let me just clear this thing so that we can just focus on the animation. So here Then what the vendor started doing is they just collapsed these three-layer architecture into two layers, and they started merging these boxes where a server can connect to two devices, two upstream devices basically. So this can be formed as a VPC. If you are talking in the Cisco context, multi-chassis lag. So that way it was providing some level of redundancy versus the earlier where the servers were single home. If there was no provision as such to make it dual home, and this VPC, even though it's very successful, or even MC lag, multi-chassis lag is nothing but your link aggregation protocol. These were very successful. Even I deploy those even today. Those are being used, discussed in the design discussions with the customers today, right? But then there are limitations around it. I have not seen a physical or a deployment where there has been more than two upstream switches. 99.9% of the deployment that you will see, the lag can only upstream the two switches. Now there are some vendors which can combine multiple of these chassis and gives additional redundancy and additional bandwidth, but those implementations are very complex. In fact, I had seen one time where we were discussing this, and customer killed that discussion right at the design phase, that they are already facing issues and don't want to club more than two chassis. But most of the chassis, most of such technologies that you see, there were two problems with this type of things like VPC, MC lag, whatever you talk. Firstly, the upstream devices can be two in most of the cases, and then it was vendor proprietary. You can't have one Juniper box and one Cisco box and create a multi-chassis lag. It will not work because there was nothing in terms of open standards that was widely adopted here. In fact, I'm not aware of any such things, and I have not even seen it. So all these problems were there, and then we did have issues here also, right? If we are provisioning additional redundancy, right, some of the links were getting blocked because of spanning tree. Then to address this blocking issue that is there between network to network, the industry came up with some more innovations that were like the fabric path, drill, Juniper Q fabric. What these technologies did is that they kept all these links unblocking, so that if there is an additional redundancy, that can be utilized by the customers. But I do see the vendor specific things here as well, and somehow it was not successful. Then after some time, there is this new encapsulation that came into picture, which was called VXLAN, flood and LAN. So at a high level, we will be discussing VXLAN in this series, but at a high level, what it did is it took the customer packet, let's say the CC packet, right, and it simply encapsulated it in an IP packet and then send over these paths. So we already know in the layer 3, we can do load balancing. We can basically utilize all our paths available. The problem that spanning tree is trying to solve comes only in layer 2. So what if, like again at a 30,000 feet for VXLAN, for the beginners, if you need to understand, just think that the layer 2 packet that is coming from the customer side, if we simply just encapsulate it in an IP packet and send it, I can take all the advantages that a layer 3 network provides to me. So if somehow I can connect the convert this part of the network in a layer 3 and start encapsulation, then I can take advantage of all my available paths, right? So basically I was solving the problem which was caused by spanning tree, right? And VXLAN is something that is open standard. So I'm solving the problems that I was discussing here. And the initial draft of the VXLAN that came in, there was no control plane that was decided at that time. VXLAN was basically how your app works, right? You for to if I want to highly simplified it, like if you want to know who, let's say, Mr. Sunil is, if there is a group of people, you come and you shout Sunil, even though everybody will listen Sunil, I will only raise my hand that okay, yes, hi, I'm Sunil, right? That I can just come and closer to you and say that okay, I'm Sunil. That way it's a unique ask from my side, but when you are asking like who is Sunil, that is like everybody is listening, right? That's a broadcast. So that problem was still here. And then that multi-chassis lag, VPC, all those things were there. But I told you that VPC, MC lag, even though this vendor interlock was there, but 2 or 3 chassis are not normally customers are okay with it. They say that okay, if I want buying something from a vendor, I can buy boxes so that I can at least use same vendor boxes to have VPC or even the fabric also, like the complete this data center fabric. Okay. But so VPC, even though or MC lag, even though these were the challenges, but we didn't hear much complaint about it. But here, even though the industry basically, so VXLAN was a industry standard, had given a solution to the problems which were there in the legacy network, spanning tree and all these type of networks. But it still has issues with respect to the flood and learn. So we came halfway, but still there was some more place to go. So that is where, let me just erase this ink again. And so that's where this BGP EVPN based solution came in, where we were using BGP in the control plane and data plane was VXLAN. Or in fact, EVPN, this control plane and data plane decoupling gives you the flexibility that in the control plane you can use this, but in the data plane you can use either VXLAN, you can use MPLS, or any other technologies for that matter, right? So now the example that I had given for the beginners who are watching this video, if the person who is coming and want to talk to Sunil, what he will do is he will go to a centralized person or let's say the security or somebody and who will say that who is Sunil. And what I had done is when I came to, let's say, this college or meeting room or whatever, I have informed this security guy that okay, I am Sunil. So this security guy knows that okay, Sunil is there inside, and this guy who is asking about me, he will simply say that okay, that person is there, right? So there is no flood and learn here. There is this BGP, there is this security guy or there is this centralized person who have the details of all the people in that room, or in case of networks, it is the BGP who have the details of all the MAC addresses which are there in the network and where exactly these are connected. Let's say this is switch 1, MAC address A is connected here. This is switch 2, MAC address B is connected here. This guy, BGP will know A is behind 1, B is behind 2. When they want to talk to each other, it will be simply a unicast conversation. Okay, so this is how it addresses the flood and learn mechanism. Right? So the journey that we look right for the data center network, which started from here and it came all the way to here to the BGP EVPN based solution. And again, I'm talking about industry specific, industry standard solutions here. There are vendor proprietary solutions that also exist and which also address similar set of problems that we have discussed in this. For example, Cisco ACI is one of them. So if you see, like again in this right, from 3-tier we have come to all this leaf spine architecture. So the changes had happened at the physical topology level as well, and the changes had also happened at the technology level as well, right? So with that, let's just see, like in the data center, why we need VXLAN with BGP EVPN. So first of all, layer 2 MAC and layer 3 IP information is distributed by a single control plane. So if we talk about MAC address, that is 48-bit, IP address, that is 32-bit, and it just happened that I was taking a guest lecture in a college, and one of the students asked that in the OSI network layer, you have explained there are so many routing protocols, OSPF, ISIS, EIGRP, BGP, they all advertise IP addresses. First of all, I did. He was asking like, sir, I didn't understand why we need so many routing protocols. But that was a different conversation. I was able to convince him like why we need multiple routing protocols. But then the other question that he asked, it was somewhere around 2011 time frame. He asked that, okay, for the data link layer or for the MAC addresses, I don't see any routing protocol that covers this. Why so? Why can't we advertise MAC addresses as well into the routing table? And that time I didn't have the answer, but now you see the answer is there. BGP just do the same. EVPN just do the same thing. And having BGP as a control plane, the way I had explained you that flooding, right, it actually minimizes this. Multi-tenancy at scale. Don't worry if you don't get this point. We will be touching this in the subsequent lectures as well. But having said that, in this fabric that you are building with EVPN along with VXLAN at the data plane, you can have multiple VRFs to segment your network. And then mobility is being handled by a robust flow control plane. So what exactly I was talking earlier, right, that not only the changes that had happened at the technology level, like from spanning tree one side to all the way to BGP EVPN, we had seen so many transitions, but we had seen transitions even at the physical network topology level as well. Like from the 3-tier, we came to 2-tier, and in fact, there was a reason for that. Like why we came to this, right? Because all these VMs that, right, this is a server, right? So here earlier the main traffic was north to south, like most of the traffic was going out of the data center. But what we had seen with virtualization, that there are some component of the application hosted on server 1 and some components were hosted on server 2, and they need to talk to each other, so their traffic will come like this. So it was like east to west traffic, and over a period of time, with more and more virtualization, with more and more containerizations, this east west traffic had grown a lot. So that's where we came to this two-tier architecture with the redundancy being provided here, and now all of these links are unblocking, right? And then if a VM need to move, let's say S1, there is a VM here which is VM1. If it need to move, it will can be moved here, and it will simply notify the BGP control plane that earlier VM1 was connected behind switch 1, now it is connected behind switch 2, and BGP will take care of updating the tables at all VDEPs, right? So that's where mobility is also being handled in a seamless way, right? So you see these data center evolutions that we have talked here, right? How we came where we are. Now let's just shift our gear a bit and talk about the campus network, right? What type of things that we see in the campus network? So more or less same stuff. This is how a typical campus network used to look like. In fact, data center picked up the pace a bit early. Campus, it took its own time, but now it is coming on the same phase. So earlier campus also like deployed in 3 layers, and in fact this was one of the most talked about design: core, aggregation or distribution, and access layer. And then you have multiple of these offices which were connected by a WAN link. Let's say this is your WAN, this is your site 1, 2, 3, you are connecting, and then there is some data centers, right, where they are accessing the services. This was our legacy campus network, right? Now most of the stuff that used to here had gone to cloud. There also many technology changes has happened, and if we want to touch, so we will be focusing on here today this piece, right? So if we simplify this, let's say even in campus we used to deploy redundancy, and STP was coming into picture. So if this is a root switch, it will like block some of these links and will put them into blocking state to avoid any loops, right? Because here in campus network as well, we used to have like data centers, our gateway on the core layer or on the distribution layer. Access was kind of still used as a layer 2, or even in some of the deployment, the distribution as well, right? So to get rid of spanning tree in the enterprise networks, there were a couple of innovations that were proposed by different vendors. One of them was stacking, where you take your multiple switches and stack them so that logically it looks like a one switch. So stacking, again, a vendor proprietary thing, and it was mainly used in the access layer so that we can stack, and then this will look like a logical unit. Then this VSS or SVL came into picture. If you are an experienced network engineer, you understand what this VSS is, and this new solution called SVL, where you take two chassis, mainly in the core, and combine them so that logically it looks like one chassis. So this was something that was deployed at the access layer. This was something that is deployed at distribution or core layer. Again, I'm not going into the details of these, how these things work actually. There are good documentation around this, but what I'm coming is to the point that get rid of spanning tree in the campus. The campus network had took a different path and solved with the technologies that we are discussing here. Right. Then VPC or multi-chassis lag. Right. But again, all these are apart from the vendor proprietary stuff, right? The campus network had evolved a lot. Even if you look at the endpoints, right? There were two things that had happened. One is the number of endpoints grown. The second is the type of endpoint grows. Right. Now, even if you take an example of a smart building, in the catalyst switches, if I look at the Cisco catalyst switches with the enhancements in the PoE area where we are talking about PoE plus enhanced PoEs, right? A lot more and more type of endpoints are being connected. Even your building management system is also connected to the switches, right? But when there are so many of these endpoints are connected, and you try to solve them with stacking virtual chassis VPCs so that you can get rid of spanning tree, and then you are doing some hacks, and suddenly your boss comes and asks about, like, what about segmentations, what about policies, what about mobilities, right? All these requirements that had come, right? How basically you will solve it. Then the vendors were actually started looking for these answers at a much later stage compared to data center, as I was saying, because there the drivers were different. In the data center, virtualization, connecting storage over the network, right? All these were some of the key drivers for the technology enhancements, right? And then had seen that shift. Here in enterprise, it started completely different, right? Now they even want a light on the floor has to be powered by a catalyst switch. There are a lot of sensors, meeting rooms. The system that is connected in the meeting room is also connected to the network now, right? So all these things, the management have all the right to ask what you will do with segmentation, policies. There is a lot of wireless stuff that is going on, right? So then these industry vendors, like the leading industry vendors, they started looking at the innovations that had happened in other fields. Like apart from the proprietary stuff that came in these campus innovations, for example, Cisco SDA solution and all. I'm not talking about that. Right. What we are discussing today is EVPN. And the vendors, when they looked at, okay, why can't we bring EVPN to the campus as well? They just thought, and then it was something that can solve the problems, right? Even though the challenges were different, but more or less similar challenges were there in data center as well. So what they came is that, okay, let's have VXLAN with BGP EVPN, And all these points I had already covered under DC, right? So multi-tenancy, right? That addresses your segmentation aspect. Mobility, that addresses your mobility concerns, right? Now, since it is a properly segmented network that BGP support with EVPN, applying policy is also very easy, right? Don't worry if you don't get these segmentation and all. I promise when you end with this series, like I need to upload those videos, you will understand what I'm talking about uh, all these, right? That will make sense to you. So, what were the key drivers, right? And in fact, when vendors start investing, for example, if I talk about Cisco, right, which is one of the leading vendor, their Catalyst portfolio is known for enterprises, and Catalyst started supporting EVPN somewhere around 2018, right? And so basically these vendors are the one who sees these pulse initially that okay, there are these challenges and how they can solve it, right? And how industry is moving towards say standard solutions, and then they start incorporating that. So EVPN was not new, it was already there in the data center, a proven solution. EVPN is already there into service provider, that we will see. Now EVPN had come to enterprise as well. And what were the drivers for this? One is industry standard solution. So every vendor's support. One fabric architecture, your complete fabric, non-blocking, layer 3. In this, and layer 2 and layer 3 information is learned in the control plane. Since we have seen how BGP had evolved over a period of time, maybe I can make some video on that, but this protocol had started its journey from IPv4. Then it came to VPN v4, VPN v6, EVPN, MVPN, L2 VPN. There were so many of these address families that were there only for the routing. Then there was BGP flow spec, BGP is used for security. You know, there is a lot, but we are not going there. But what I'm trying to say is that this solution, even for enterprises, was built on a proven technology, right? And it provided a very flexible design, like we had seen mobility, right? The same principle which we had seen in data center where a VM moves, right? So BGP updates the tables. In case of enterprises, it is actually endpoint which moves. So from BGP control plane perspective, it is same, right? So I hope by now you are able to understand the drivers behind EVPN for enterprise, for data centers. Now let's take a look at the service providers. And in this, we will actually, there are multiple challenges that solve, but we will start with the very basic ones, right? So a service provider is one who actually connect multiple customers. Let's say, oh, here is a typo actually, because this is, let's say, CE1, this is CE2, and they are part of a enterprise. So CE1, if we need to talk to CE2, it will connect to the providers, right? So what the provider will do that, okay, to provide end-to-end connectivity, and then there is this packet that comes, let's say in this direction. So I have my application, I will put the IP header and then the Ethernet header. What the SP will do, it will take the packet, let's say this is layer 3. So it will take the packet, it will put some sort of encapsulation over it, right? and then it will send the packet in this direction. So the packet gets delivered end to end. Now let's go a bit deeper and see how it actually works. So again, we are talking about layer 3, CE1 to CE2. So the same packet that comes, when it hit PE1 and PE1 send it forward, again it is a layer 3 packet. So we don't need to carry this Ethernet header, this one, right? So we can eliminate this. We can take just that layer 3 packet, right? And then we can put some labels on top of it, right? The VPN label and the transport label. Those of you who understand L3 VPN working will be able to relate it. If you are someone who doesn't understand, don't worry, just think about that there is a packet that came to you. You had simply encapsulated it, and then this encapsulated packet you are sending to the other end, right? Then on PE2, it will, when you are handing over the packet at other end, you remove whatever you have put. So I will remove these two labels and will send the IP packet as it is. Right? Of course, I need to put this Ethernet header, but this Ethernet header is for this segment. This was for this segment, right? So that's how simply your packet flow work in layer 3. One thing here, just one more here. VPN v4, I need to have a address family in BGP, which is called VPN v4. Okay, that supply this label. Okay, if you don't understand anything in this slide, it's okay. Just understand this point, that there is a separate address family VPN v4 which supply this label. Now, with the evolving demand, of course, customer says that layer 3, okay, you connected, fine. I want to connect layer 2 now. So what they want to do is, from CE1, they want to connect to CE2, and both of them are, let's say, into the same subnet. So this whole cloud that you see from here to here should transparently carry that layer 2 packet. How it will work? Again, same way. Ethernet header, IP header, and application data that came from customer. But this time, because it is layer 2, I need to carry that Ethernet header also with me, right? And then on top of that, I will add the service label or the transport label on top of that. Same way, analogous to VPN v4 label, this transport service label, but you see the service label and transport label, two labels are there. And then when at E2, I will simply remove these two and will send the packet toward the CE2. But in this case, to supply this service label, I will have basically multiple mechanisms. But if we just talk about, let's say, a BGP implementation, then it is a layer 2 address family, right? Or VPLS, so this extending this layer 2 is called as VPLS if it is multi-point, right? Or there can be a point-to-point as well, which we call as pseudo wire. Right? So when you say pseudo wire, it is point-to-point. Like for example, this can be a pseudo wire. Or if there is, let's say, a P3 here, and I have C3, if now these three need to talk, it will be VPLS. And to supply this label, right, there is a new address family in the BGP that was proposed, which actually supply these labels. So you remember there, like I was talking about VPN v4, so that was VPN v4 address family. Here we are talking about a different address family. So my question is, why we need multiple of such address families in BGP for layer 2 or layer 3? Can't we have only just one address family which suffix all these requirements, like my layer 2, layer 3? Because they are not new. They are there since ages. Answer to that question is yes. With EVPN, you can do that. Right? EVPN basically does this. But is it the only thing that EVPN do? In case of service providers? No, the answer to that is there are multiple other drivers as well. But since this is a very beginner level session, right, I just wanted to keep it very simple, so that I'm just telling you this. We will uncover some of the problems that are caused by VPLS, and that has actually resulted in enhancements of BGP maybe in the upcoming session, right? But for today, you understand it like multiple address family for layer 2, layer 3 can be unified with EVPN. So technology is there. Customer will use, not use, that is something we need to see. And in fact, there are multiple point of view there. But I hope you got the point that I'm trying to make here, right? So now let's just break down these overlay technologies. I'm talking about this overlay, underlay for quite some time now. So when I say overlay, as we had seen in the previous slide as well, it can be layer 2 or it can be layer 3. To support, there are these multiple technologies that existed, and then how they are consolidating into EVPN is what we had seen in this lecture so far. Then we have talked about encapsulation, right? So we have looked at VXLAN mainly because that is being used in campus, that is being used in data center. But service provider, right, as we had seen in the last, they use MPLS, so basically labels. Then there is this underlay network, right? Because all these services are riding on the network, so that network need to be connected, right? So that underlay network is simply a set of nodes which are connected to each other, and then we have taken the complexity of multi-tenancy, layer 2, layer 3 services, anything here. And how this is supported is via this control plane, where BGP is responsible for learning the MAC addresses which are there locally connected, remotely connected, how it discover the peers and all, right? So that is in the control plane. And then in the data plane, it basically support all type of traffic which can be in the overlay, be it layer 2, layer 3, it can be unicast, it can be multicast, or in case of layer 2, it can be bump traffic as well, broadcast, unknown unicast, multicast, your ARP traffic, let's say. So it transparently support all that, right? So I was talking about this, right? L2 VPN, L3 VPN, and I had shown you in a service provider network how we are using different address families. Do we need to use one for that? Technically, it can be used, but what we had seen is that for the layer 3, SPs have already enabled this VPN v4. They are very comfortable with it. So they are not looking at migrating their layer 3 services to EVPN, but definitely EVPN brings a powerful feature set within L2. So for the layer 2 case, they can use EVPN, and all these are address families, they can coexist with each other, right? So even though technologies are there, but SPs had like already deployed, there are no major issues with VPN v4. So what I had here during my conversations with these, some of them are very large tier 1 SPs as well, and they are not interested. But layer 2 in EVPN in the service provider, there is definitely interest. EVPN in the data center, there is still definitely a very good interest. A lot of data centers are live with that. Campus EVPN, there is a very good interest, and even for L2, L3, EVPN is picking up the pace. That's what I can see in the field. Right. So now, so far into this lecture, right, we are like close to 50 minutes into these conversations, talking about data centers, talking about enterprises, a brief touch on service providers, right? Now, let's connect all these dots together. So if it is a traditional network spanning tree, you are using some sort of lag, multi-chassis, VPC, or is this point-to-point service, virtual private wire services that I had shown example, I called it pseudo wire, right? Or VPLS. The answer is EVPN. If you have multi-VRF, MPLS VPN, some sort of tunneling, answer is EVPN, right? And this is applicable for data center, campus, service providers, right? So if you want me to list down some points here, from bridging to routing, right? Remember that student's question that I was talking initially, why can't we route MAC address? So routing the MAC, it provides integrated layer 2 and layer 3 services. It all provide L3 like principles, active multi-homing and load balancing. You can leave this piece for now. If you don't understand, I will cover it in the upcoming lecture. But in the layer 3, we had seen that load balancing is one of the advantage, right? Then control plane based learning, we had seen that BGP is used. Bump traffic, you can use any choice of your data plane, VXLAN, MPLS, whatever you want to use, right? Or even MPL, or going forward, there can be SRv6 as well, right? And then it is a industry standard as well, right? There is nothing here which is vendor proprietary. So let's just look at the three domains that we had talked and connect these three domains, and then see whatever we have discussed so far into this lecture, how it all actually tied up, right? So let's start from, let's say, our SP. So this is our service provider which have these PE routers, right? These are maybe L3 switches connected in the SP data center, let's say, right? So here, what we used to have earlier is VPN v4, v6 address family, VPLS, pseudo wires, right? In the control plane. This can be for layer 3. This is for layer 2. Even there is a BGP also that exists for layer 2 here to transport that level to layer 2 information, right? And in the data plane, it was MPLS. And with MPLS, you need to distribute the label. So you use either LDP or RSVP. Right? Don't worry if you don't understand this. This is not a class on MPLS, right? But you see, This is control plane, this is data plane. Then we come to our campus side, right? So this is our campus switches, this is enterprise, right? This is enterprise switches, these are WAN routers, right, connected to the SPs, right? Here what we used to have earlier hierarchical network or routed access, right? When I say hierarchical, it was like that access, aggregation, core, or routed access means we have not talked about it, but routed access was also one of the enterprise architecture where you define the gateway on the access itself and then completely use the layer 3 network. So here you either carrying layer 2 or you are carrying your IP packets, right? Then we come to the data center. So let's say this is data center, these are our servers, right, where some servers are connected, and let's say a typical enterprise which want to communicate to these data centers. So in the data centers we had earlier that 3-tier design or fabric path or trail, and then in the data plane it is either layer 2 transport or IP packets that we are delivering, right? But how does this translate to a new architecture that the customers are considering today because of all the challenges that we have discussed here, right? So between the data center and service provider, you have a common control plane, which is called BGP EVPN. And as I was saying, like not many customers want to move from their VPN v4, even though EVPN supports it. So they can have this EVPN stuff as well, right? And then in the data plane, it is either MPLS or SRv6. MPLS or SRv6, or it also gives you a flexibility to use or continue to use VXLAN. Right? And then on the campus side as well, SDA, software defined access, again a vendor proprietary stuff, technology, but EVPN that can be used with layer 2 IP or IPv6 as the data plane. So you see this point here. So it's a unified technology for campus, for data center, for service providers. So we have discussed certain challenges. So I hope that had made the clear point that why we need EVPN, right? And then the agenda in our topic was also there that why you need to learn EVPN is either you are working here or you are working here or you are working here. All the way it is same, right? EVPN in one or other form. So with that, we would like to conclude this. I hope this was something that was informative for you, and I would like to say thanks a lot for viewing.